In 7.4, we're going to estimate the population mean differences and the population proportion differences. So going through this, first off, we have to look at independent versus dependent. Independent is two samples are independent if sample data drawn from one population are completely unrelated to the selection of sample data from the other population. So, for example, randomly assign students to subjects to two groups. One group gets a placebo, the other one is given a specific treatment. Two separate groups, two different people. Dependent is when two samples are dependent if each value in one sample can be paired with a corresponding data value in the other sample. So a group of students in an English class given a pre-test and the same students are given a post-test at the end of the course has the same group. So independent means you have two different groups. Dependent, you have the same group before and after. Now, as we go through these, we need to have two independent, so two different groups. Now, our first one here is going to be when we know our sigma. Remember, if you know sigma, that means we have to then use our z table. So you're using the pretty little table on the z table that we have with all the confidence interval percents. Now, going through these, we now have to take x bar 1 minus x bar 2 minus e, and then mu 1 minus mu 2, and then x bar 1 minus x bar 2 plus e. So as we go through this, we're now subtracting the two x's and then subtracting e, subtracting the two x's, then adding e. Now your e gets more complicated. So now you have to take your ZC square root sigma 1 squared over n1 plus sigma 2 squared over n2. So make sure you're going back to this. Now, obviously, for both of these, you still have to have your n's being bigger than 30, or they have to tell you that you have a normal distribution. Now, you're going to be given some long story problems with these, so I would highly suggest that you underline, highlight the important parts, because sometimes they might give you paragraphs of just reading, but you just need the numbers. So the important things that we are going to need is the x bars, the sigmas, and the n's to go through these. So here we're looking at fish. We're looking at fish caught before and after a fire that happens. So your N1, all that stuff is before the fire. Your N2 and all the 2s are going to be after the fire. So we have an N1 of 167, X bar 1 of 5.2, standard deviation 1.9. We've got an N2 of 125, X2 of 6.8, sigma 2 of 2.3. So sometimes it might be easier for you to just find all the important information first and then figure out what your sentence will be later. So we're a 95% confidence interval. So right now you're finding your ZC as we go through this. Again, your ZC, so you're going to your little chart, looking at your ZC. So now when I go through this, my ZC would be a 1.96 there. So for our equation, so I have 1.96 square root. I have 1.9 squared over 167, 2.3 squared over a 125. Again, you need to make sure you're typing things into your calculator correctly. So double check typing it in. It should round to be about 0.50. Don't just go with my answer. Make sure you know how to type it into your calculator. As always, send me questions if you've got how to type things in. I can try to do a little recording on my iPad if I need to show you how I would type it into my calculator. Because again, different calculators are different, so I want to make sure we're looking at things right together. So to find your interval, x1 bar minus x2 bar minus e, mu1 minus mu2. x1 bar minus x2 bar plus e. So now you're just plugging everything into the formula. So when I subtract those, negative 2.10, and when I go through those, I got a negative 1.10. Now you're thinking, those are both negatives. Should I have two negatives? Yes, it means something. So if you have two negative numbers, think of what that means. The first number minus the second number gives you negative. So that means the first number has to be smaller than the second number. So we are saying the first group has to have smaller numbers than the second group. Now, the first group in this story problem was the number of fish before the fire. The second group was your fish after the fire. So if we're saying the first group had smaller amounts than the second group, we are saying that the fire increased the population mean of our forest that we have here, the Yellowstone National Park. So going through this, we are saying that the first group has smaller amount of population mean than the second group. So I'm going to make sure I write that down so you remember it too. So since both numbers are negative, we're saying the first mean, population mean, is smaller than the second population mean. So the meaning of this interval is we are 95% confident that the population mean of the catch per day before the fire was less than the population mean of the catch per day after the fire. Since the interval contains negative numbers. So again, going through these, if you have two negatives, you're saying the first group has a smaller population mean than the second group. For our next one then, we're going to go through these without knowing our sigma. So now we have S. Remember, if you have S, you've got to use the T table. So that means you have to search with your degrees of freedom and your percent. Everything else is pretty much the same. So you have the same way to figure out what your interval is. You have the same way to find your E, except now it's T and S instead of your Z and your sigma. Again, underline the important parts. So we have our N, our X, and our S, our N, our X, and our S. So here we're looking at brainwave activity between 4 and 6 a.m. of two groups. One group is going to be given a half liter of red wine before going to sleep. The second group is given nothing. And they're measuring to see what their brain waves are from 4 to 6 a.m. So looking at these, they're trying to compare if either one of those have more brain activity or less brain activity during that time. So now going through these, remember, we've got to figure out what our TC is. Now, important to note, we have two groups here, so you're thinking, I've got 2 degrees of freedom. When you're trying to figure out what degrees of freedom to use, we want to go with them the smaller of the two. So again, if you are confused as to what degrees of freedom to use, whether the N1 or N2, go with the smaller one that gives you degrees of freedom. So always stick to the smaller N. So if I look at my two groups of 15 and 14, 14 smaller, so the degrees of freedom that we would use here is 13. So on your T-chart, you're going to look for 13, and we want 90%, so 0.900. So again, 13 and 0.900. So look that up in your T-chart. We should get our TC to be 1.771. So now we've got our E. Okay, so I have 1.771 square root. We've got an S of 1.86 squared over our N of 15. We've got an S2 of 1.91 squared over our N of 14. Again, make sure you are typing this into your calculators correctly. So don't just go with my number, go with what you have on your calculator. If you're not getting it, keep trying. So I have an E of 1.24. So we're going to plug everything in. I'm running out of space, so I have to go to my next line. Okay, so for the left side then, we should get about 11.82. For the right side, we got about 14.30. Now these are giving you two positive numbers. So if it's two positive numbers, you're saying the first group is bigger, because a bigger number minus a smaller number is going to be positive then. So both numbers are positive. So that means mu1 is greater than mu2. Our mu1 is the group that has the alcohol. Our mu2 is the group that doesn't have the alcohol. So we're saying the group that has the wine is going to have more brainwave activity or be more awake than those who didn't have it from 4 to 6 a.m. So we want to write our sentence then to reflect that. We are 90% confident that the population mean brain activity for the group drinking wine was more than the population mean brain activity for the group not drinking wine, since the interval contains positive numbers. So again, positive numbers means the first group would be bigger.